This is example 12.8. And it is called speed of efflux. And it reads, figure 12.5, and you just have to you're just gonna have to look at it in your book. It's page 383. Figure 12.5 shows a gasoline storage tank with cross-sectional area A1 filled to a depth of H. So A1 filled to a depth of H. The space above the gasoline contains a pressure at P naught. The gasoline flows out of the bottom through the tank through a short pipe with a cross-sectional area A2. Derive an expression for the flow speed in the pipe and the volume flow rate. So we're going to use Bernoulli's equation, which says the pressure on one side, P naught, plus 1/2 rho V squared, and that's just the kinetic energy, plus P rho GH, and that's the gravitational potential energy, is going to equal to the pressure on the other side, and it's flowing out, so that's going to be atmospheric pressure, plus, this is V1, by the way, 1/2 rho V2 squared plus rho GH here. Okay. And this H, this is going to be 0 because this H is relative to here, so that term is going to drop out. So we want to solve for V2. So V2 squared is going to equal to, doing the math here, is going to equal to the square root of 2 times that pressure differential, P naught minus P ATM, over rho plus 2GH. And then from your continuity equation, or from your volume flow rate, I'm sorry, let me get a different color. dV dt is going to be equal to dV dt is going to equal to V2 A2. So this times A2, this guy, times A2. Okay, this one said is the Venturi meter. Shows a Venturi meter used to measure flow speed in a pipe. Derive an expression for the flow speed V1 in terms of the cross-sectional area A1 and A2. And the difference in height H of the liquid levels of the two vertical tubes. All right, so what you got is something here. You got a vertical tube here. There's a pressure which is causing that liquid to rise. And you're squeezing it through this thin pipe here. You go into another section. You've got another Venturi tube here, and it's at a different lower level. So you got this is delta H. And you've got your flow rate going this way. And we're taking the velocity in here and here. So we have that MGH is going to be the same because the heights here are the same. So we're going to eliminate that term. We're going to get P1 plus 1/2 rho V1 squared equals P2 plus 1/2 rho V2 squared. And let's see, what are we solving here? Determine an expression for flow rate V in terms of the cross-sectional area A1 and A2. Okay, and from the continuity equation, we know that V2 is going to equal to the A1 divided by A2 times V1. So now all we have to do is do P1 minus P2 is going to equal to 1/2 rho times V1 squared minus V2 squared. And we know that, let's see, I've got to substitute a value for V2. So I'm going to say this is going to equal to 1/2 rho V1 squared minus A1 over A2 times V1, and this is going to be squared, squared, and squared. All right, let me clear a little bit here. All right, so now I'm just going to do a little algebra, and I'm going to get pressure 1 minus pressure 2 equals to 1/2 rho V1 squared times 1 minus the ratio of the area, A1 squared over A2 squared. And let's see, solving for V1 now, right? Is that all we have to, oh, the pressure difference, now the pressure difference equal to rho GH. Okay. Also, P1, P1 minus P2 is going to be equal to that Venturi meter, which gives you the rho GH. So that's going to be equal to, let's see. So I've got P1, P2, I'm going to take this and this guy. And I'm going to get rho GH is going to be equal to 1/2. I'm sorry, I'm taking this guy. Yeah, that one. V1 squared minus 1 minus A1 over A2 squared. Oh, I had a row here. Yeah, I had a row there. And those go. So I'm going to get, what am I solving for? V1 is, okay, need some board space. Okay, V1 is going to equal to, squared is going to equal to GH divided by 2GH over 1 minus A1 over A2 quantity squared. Wait. I'm going to subtract that from both sides. So this will be negative and that'll be positive. And then taking the square root of both sides. And I'll get V1 equals the square root of 2GH divided by A1 over A2 minus 1. And there you go. That was 12/9.